what we're going to be going over here is a linear programming problem where we're going to be optimizing some profits here, and we're going to be calculating the best product mix here based on some production plan. And it's going to be based on changes that we have in our resource availability here. Also, we're going to have some locked-in sales requirements, and then we're going to explore the shadow price benefit for this example. Okay. So the first thing we want to start with is with our resources that we have available here. When we're going to have two different products, we're going to be manufacturing product P and product Q, and then we're going to have some unit costs for each of those resources that we have. And we're going to have some labor, L, represented by L here, material A, material B, and also some machining represented by C here. And we have our, on a per unit basis, I'm showing the requirements for each of those resources here. Okay, and we have the per unit cost here as well for each of those resources for P and Q here. So what you're going to do here is just set up your equations here where you got for each of those resources labor. All you do is just take off your chart here, your unit or requirements here. Just that would be 3P for labor plus 5Q here for labor as well. So labor here, just 3P plus 5Q. Same for material A, material B, and material C. You just work off your unit requirements here. We're going to include these costs later here, but we'll just start with the units required, less what we require here, and not include our costs at this point here. Okay, so we've got our usage here for product P and product Q. Now we come down to our production plan. So this is what we're going to have. We have the resources available here again for labor. There's two materials and then some machine capacity here. So this is what our original plan was set up here. We got so many hours. I'm not going to go through them all here, but I got so many hours or units here for each of those. So many labor hours here at 7,500. Material we got at 8,500 units, whatever it might be in pounds or whatever. And then that's for material A. Material B is 3,000. And then machining here, we have 7,500 hours that are available. Now we come along here and we revise this original plan, and we'll just say we're going to reduce those requirements here by 10%. So just take 10% of each of those available amounts here and take that 10% here, and we're going to be subtracting from those. But we also have the situation here where we have sold so many of product P and product Q here, 250 a P and 350 units a Q here. So we're going to have to set those aside in our production plan. That's already locked into our production plan. So what you want to do is you want to just take your usage that you have for each of those by units here for each usage for labor, material, and machine capacity here. Just put whatever quantity you have here for 250 Ps here and 350 Qs here. Just slip those in, and that's going to give you the amount that we've already sold or we've used here, or that's not available. So just that'll give you those quantities as well here. So this amount, let's just say those were sold units here. You just subtract that from what's your available plan here. But remember that available plan was reduced by 10% here. So you'd subtract out your 10% here. Reduction of 10%, say that was 750 here from a labor available 7,500, and then an amount that we sold or we already have locked in. That's based on those unit resources that we have for both P and Q here. Those we take those amounts, subtract those, and this is what the quantity available is that we're going to be dealing with. So this is what we're going to have to maximize our profit or come up with the best production plan based on our available quantity. Also got some maximum sales here based on maximum sales, some quantity. We're not going to really deal with that, but you could work off that as well here if you have to. But you'd want to look at that here, maximum sales versus available capacity here after your reductions. But that isn't going to become a factor in our problem here. Okay, so the next thing, let's just go, and we're going to just start out with really a two-dimensional linear program here, and because when we work beyond two variables here, we get into problems when we start trying to visualize this, looking at it on a graph here. We have to move into different dimensions here. So what we're going to do here, we're going to just say we're going to be maximizing some sales dollars here. And for those two products, I got sales here, the price here, the selling price for product P here is $130, and for product Q here is $160 per unit. So that's going to be our objective function here in our linear program here. Okay, so we got that. Now just for this basic program here, just take, and we have to set up our maximum constraints, our maximum availability here based on those constraints here. So what we're going to do is just work off, for example, P and Q here, just take them off those amounts that we set up here in our equations. That slips right into our linear program here, labor, material A, material B, and material C. And then we have, in this case, it's less than or equal to, and the maximum amount here, that constraint amount, is just, we can go back down here and look at, that's just that quantity that we had calculated here that we have available, that's remaining here. Remember, we reduced our original quantity, plus we used up some of the capacity here. We have that locked in. So this is what we're going to be dealing with here when we're trying to maximize our sales dollars or come up with the best production plan here between product P and product Q. Come up with the best quantities for each. And then we also have another requirement here for product P. We have a market requirement where you cannot sell more than 500. We're not going to be able to sell more than 500 units for product P. In product Q, we can't sell more than 800 units. So set that up into your equation here and just set these in as an inequality here, less than or equal to 1P here for 500, 1Q here for 800. Okay, so now if we go over here, just working off our simple linear program that we'd have set up here, you can look at it here in 2D in this, because we only have two different variables here, P here along the bottom axis and Q along our vertical axis here. So what you're going to do here is just to lay it out here, all you'd want to do here, and I want to get into all the details, just take for P here, for Q here, we have 800 units, that's that blue line. We have a constraint. These are constraint lines that we're laying out. We're just laying it out here in constraints here. For P or Q, what is it? Q, we have 800 here. P, 500 here. So that's the constraint. And then we got these other constraints, just to go to them. To lay these out on a graph, all you do is set, for example, here to solve for Q, how many units of Q you'd have, just set P equal to 0, solve for Q. And then if you're solving for P, just set Q equals to 0 and solve for B for your equation. So what you're going to do here for each one of those things, let's just go through for our labor here, let's look at it. We've got a constraint here, it's that red line here, 3P plus 5Q is less than 4,250. And then we're going to have another, that's for that one here. Then we got that $5,000 for our material A here, that's that gold line here. 5P plus 4Q is less than 5,000. And then we're going to have one here for material B, 1,850, that's that green line here. And then we also have this materials, a machining C here, 4,600. That is a red line, or excuse me, another green line here. So really what you're doing here is, and just remember here, we're assuming that the costs are not included here when we're dealing with this here. So all we're doing is we're taking our sales here, that price per unit here, adding those together, and that's going to give us a gradient line here. That's really the slope of that line here. But what we're trying to do here is just come up with our constraining. See, we got our different constraints. Follow along look at your constraints here, check your corner points here, and you're going to find out that, put in your P's and Q's here, and you're going to find out that the maximum amount based on your constraints here for P and Q for maximizing those profits is 500 here for P. We met our constraint here, it's this point right here. And then 550 for Q here. Okay, well I know that because I put it into this linear program here, solved at 153,000 here in sales, P set at 500, Q set at 550. All right, so this is our feasible area here in this green area here, but we come up against those constraints because we cannot sell more than 500 units of P here. And then we have this 4,250, that's that labor constraint. We don't have any more than 4,250 hours available in labor. Okay, so we come up that. All right, so that's just looking at it from our simple terms here. But when we do enter those costs in, and we'll go look at it, we're going to come up with a different solution. We're going to come up with 500 here for P, but our Q is going to move up to quantity we'll be able to sell 650. So the reason I come up with that here, when you're going to add in all those costs, you cannot lay it out in 2 dimensions here. You come into some radical drawing. It's really multiple different drawings that are dimensions that you're working with. So I'm not including them. I'm just showing it. We're going to come up. It's going to be at this point here versus what we have here. And it's because of those costs that we're going to be adding in here. And we're going to be bumping up against some other constraints here. Okay, so let's go down and let's look at the program that we're going to really set up here. So what we're going to be is we're going to be looking at our objective function here is just to maximize the contribution margin here, because that's what you deal with in accounting or cost and accounting. And that's really taking the revenue minus your variable cost here. So remember our revenue, we had that 130p plus 160q. That's what we were looking at our sales here. But now those variable costs, what we're going to be looking at, and if you've gone back to our cost chart here, or you're going to see for material A, it's going to be $3 per unit here. Material B, $7 per unit, and then labor we're paying $8 per hour here, and then we have some material costs C, or machining costs C here, we'll just say $10 per unit. So everything here is on a per unit basis, and that's gonna be our variable cost. So you can see we're subtracting those from our to come up with our contribution margin. We're subtracting that variable cost here, shown in green, from our revenue here for P and Q that we show here. And we want to use only the amount that we need here. So this is how we set up the program here. Same program as we had up above here for our maximizing our sales. The only thing that we're slipping in here is on our constraints here for each of those constraints that we have here for our labor, material A, material B here, and our machining hours that are available here. Just put in a minus and then put your variable amount here. I'm showing the letters. I got P, Q, that's coming off our other program, or off our resource, our bill of material, really, the requirements for those bill of materials here. And then for these other ones, just what all we're going to do here for our labor, put in a minus L here, minus 1L, material A, a minus 1A here, and minus 1B for B, material B, and then machining cost minus 1 here. And then put in that resource, the maximum resource that's available that we come up with off our equation here. So really what you're doing here by adding in those negatives here, you're setting up the case here where you come up with you're not going to have any more material in this linear program or more labor. So let's say you're going to use only the amount that you need here by subtracting those out here. So you come up with a unit amount here, and you just leave your inequalities here at less than or equal to, and those are our constraints here. And then just remember, everything else has to be a positive. Primal has to be a positive here. And what this is a maximization linear program here. So you got your resources or your supply here, and then your demand for your constraints or your capacity constraints here. Okay, so what we're really getting down to, the other thing here, we can run our program here, and we'll come up, or just go down here and look at it. You're going to come up with your maximum contribution by 164,700, and you're going to come up with P equal to 500, Q equal to 650. That's based on the resource constraints you have here. But we want to get into the shadow price or the dual price here. So what you're going to do here, let's look at each one of these constraints here. For labor here, we only have 4,250. So we're going to slip into our program, just put in 4,251, run your program, and you're going to come up with the benefit additional unit here. By adding that extra hour here for labor, you're going to come up with a benefit of $29 here. So what it really does is, and we'll look at that in detail, all it does is take that contribution margin up here, and it increases that contribution by $29 here. Okay, so that's the benefit additional unit. We'll get into that deal. We'll go over that in detail here later. And then material A, just put in from 5,000, 5,001. You're going to come up with a dual price here, or a shadow price here of $3 here. And then do the same for material B. Slip the 1,851, you're going to come up with 0. And for machining C, 4,600, 4,601, you're going to come up with 0. So what that's really telling you here if we gone back to our constraints up above here, when we've got these 0 values here, that means we're not bumping up against any of the constraints here. So we got plenty of material B in machine C here. So, and we'll go up. Maybe we should go up and look at that here further here. But that's all it's telling you here. But we're sort of bumping up our labor constraint. Remember, we come up against that here. And then we also have some material A here. Well, when we laid it out in 2 dimensions here, you wouldn't see that material. You would see the labor constraint, but you're not seeing the material A constraint here. If you looked at just these maximizing the sales themselves here. But when you add in the cost, you're going to come up against the constraints. And really what this is telling us here, and we're going to look at the benefit addition, is this benefit has to be greater than the cost here. So really our cost here for labor is $8 an hour here, and for that material A is $3 per unit or whatever that we're using here. So in this case, the benefit here, $29 here, is greater than our cost here. But as we're going to see here, this $29 is actually in addition, a benefit in addition to the hourly labor cost here. But so that's what you're going to have to do here. Do you have to pay overtime, premium time, or exactly what do you have to pay to increase your labor dollars here? Do you have to add more, hire more people, and so forth here? Okay, so that's what we're talking about when we're talking about a due price here or a shadow price, and we'll get into detail on that here. So really what you're looking is your benefit that you're going to receive here on a per unit basis here by increasing your resource here. Is that going to be greater than the cost? Okay. All right, so we'll move on. Okay, now let's get a better understanding of this shadow price or this dual price. Now remember, for each of our resources here, I increased them by a unit of ones. For example, that labor went from $42.50 up to $42.51, and what we came up with is a shadow price or dual price here, $29. And really what you're doing there is you're just taking your maximum, in this case the maximum contribution margin that we have here for 4,250, and compare it with the when you add that 1 unit here to increase it to 4,251, and the difference here gave us an increase here in our contribution margin of $29 here, and did that for each of the other constraints or resources that we have here. And the only other one was that material A here. You increase that up to 1 unit here, and we come up with a shadow price of $3, and all that did is increase our contribution margin here by $3. Now we did that for material B and material C here, each increased those by a unit here, but come up with nothing. There was no increase here in the total contribution margin because they're not constrained. We haven't used all the capacity up here, so they're not constrained. Okay, so what we really mean by this shadow price is really the premium above the current cost here. So for our example here, we're paying $8 an hour here for labor here. And when we added that extra hour of labor, I come up with an increase here in our total contribution margin of $29. So we already spent $8 here on labor, and we get $29 back here in addition to that. So that's what we're talking about. The shadow price is a premium above the current cost. That's in addition to the current cost. Now, the question is, we got 2 questions we're going to have to answer here. Is what amount of money can we pay up to in dollars per hour here to use that premium above cost? So let's just say we had time and a half here. We moved it up from $8 to $12 an hour here. So what you're really doing is you got that premium here of $29. So you increased it by $4 an hour here. So your net premium is going to be the different. We're going to reduce the $29 premium down to $25. So really that's what you have to look at. We're going to pay up to how much per hour here. If you have to add on more labor and so forth here, then you're going to have a greater cost. So really that's the question you're going to have to look at. But when you're doing a linear program here, do not make this mistake. So if I just said, okay, I'm increasing it by $12, so I go up to my equation here and go from $8 to $12, well, that's increasing all the labor that's being used here. So there I'd come up with a net loss here of $2,000. So really what we're talking about is only that last, the additional hours that you're going to spend here. They don't get included in all the hours here. But the big question that we're going to expand on here is how many labor hours can we actually add here and still have a benefit? That is, sitting here at 4,250, how many hours can I, what is our constraint here? Can I move this up to 4,600 hours, 4,800 hours, 5,000 hours, and so forth here? So we can get that answer just by looking at it on our graph here. Now remember, this 2D graph here, that doesn't include those costs here, but we have to work off that because we don't have any other way to really look at it in diagram form here and plot form. So what I've done here, I've taken that 4,250 hours here for that labor constraint, and it's that red line here that's constraining our labor, or constraining our profit here. And I kept on moving it up. I actually moved it up. I increased it, increasing our labor. I went from 4,250 up to 5,500 hours here. And that's at that 5,500 hours, that's the point where there was no marginal increase here in our contribution margin. Our shadow price becomes zero here. But that's really irrelevant because at 5,000, increasing our labor to 5,000 hours here, that's where we come up against our constraints here. We have a maximum 800 units that we can sell here at product Q per the market here, and only 500 for unit product P here. So really, you have to look at that. So really, I could increase those labor hours here from 4,250 up to 5,000 hours and still have a benefit. And really, if you look at it in terms of the graph here, what you're looking at in terms of a graph, we had this red line here, and it's awful busy here, I realize that. But what you're doing is you're paralleling that red line. Each time you add some extra labor hours here, say 4,250 to 4,300, that line is just moving up in that, on that slope, moving up parallel to it here. So here's where I graphed it out. I come up to 5,500 hours, and it's really, it should be a little bit above where I have the intersection here where we come up with maximum sales or marketing constraints here for both of those products here. But that's the idea of how it works here. All right, so not to confuse the issue here. So again, this graph here assumes that our labor was sitting at $8 an hour. So really, to sum it up here, the shadow price increases the profit here at $29 per hour here until labor is no longer a constraint. Then the next constraint takes over here, and then the shadow price on our labor here becomes zero here. So actually, when we moved it up here, we come up against some material constraints here, pretty busy here, but that's just to demonstrate here what we're actually doing with that shadow price. Every time we add some labor hours here, whatever that constraint line is, we're just paralleling it up here, moving it up at that point until you hit another constraint here. Then in this case, our labor doesn't become a constraint. It's probably going to be some machining or material here. All right, so we looked at it in terms of labor. And just to go down and get a little better understanding here, let's look at it down here. So I've got the profit here. This is, I actually run this my linear program here. I got the profit, and then against those labor hours, it was increasing those labor hours. And then we got the quantities for product P and product Q to quantities. And then this is the deal here. This was that shadow price here. That was the benefit above our $8 labor cost. So remember that $8 labor cost is included here in our profit, and this is what we're benefiting from here. So if we just looked at that 4,250, that was sitting at 4,250 labor hours available. That was we could sell 500 of product P because we come up against their maximum sales or marketing constraint here, 500 units. But product Q, we come up to 650. We got a maximum of 800 we can sell. So I just added that one more hour here from 4,250 to 4,251. Product P, still at 500. That was the max there. But product Q, well, it's 650.2. Well, you're not going to sell 0.2 units here, but nonetheless, that's what it would come up to. And then our shadow price here was $29 based on increasing our labor hours here by 1 hour. Then I jumped up here just to go through the arithmetic. Labor hours bumped it up to 4,600, profit going up here, and then product P 500, product Q 720, and did my division here, and I still come up with the shadow price here on a per unit increase in those hours here from 4,250 to 4,600, $29 here and 60 cents. So kind of holds true, that shadow price. when I moved it up there. And then bumped it up here to 5,000 labor hours, 5,000. We come up with a maximum profit, 185,900. You can see it's increasing here. And that's where we met our maximum product P here, which we had all the while here. But we actually met our Q maximum sales here for Q800. And there you can see our shadow price, or we still had a benefit here of $28.27 here. And then I went all the way up. Now you can't do this here because we can't even sell more than that. But I went up to the point here where that shadow price changes from that 29 or that $29 down to 0, and I came up with adding up to 5,500 labor hours here, and that pumped up my profit as well here. But then I met the maximum production. I couldn't make any because of maximum production here, but nonetheless, that's just to prove the point here on that shadow price here. So you have to be careful at looking at shadow prices and how you calculate them. You have to match up look at your other criteria here, but just putting it in the equation, that's what I came up with here. And then one other last thing here, just moving over here. You know, we worked off that 2D graph here, and we're moving all around here and all those different constraints here. And the big thing is we would like to work in 3D, but it's with all those variables we're dealing with. We actually have 6 different variables we're dealing with here. But we can get some idea what's going on here, because if you have a software package, you can get the you can graph it out here. Some of them do the graphing. I'm using MapleSoft here, so I can graph really 2 variables against another variable. So my product P quantity here, Q quantity against the contribution margin. So I got some profit grained here, and it's pretty hard to see here. You can wiggle this thing around here, but it came up with against those constraints here in a 3D dimension. And we couldn't actually come up with it in 2D here, but it gives us some relative idea what we're talking about when we're looking at 2D, a 2D graph here that product P and product Q variables against those different constraints here. Okay, so that's just the idea of what's going on here. Gives you a little better idea here if you actually have some means of looking at it in 3D here. And again, in 3D you're restricted. You can only go against really 3 different variables, and you have 6 different variables you're dealing with in this problem here. And in most problems you're going to have any number of different variables, but again, this is just for demonstration purposes to get a little better understanding of what we're talking about here when we talk about shadow prices and so forth. Okay, so that'll summarize our discussion.